Hello, my name is Francis Awejo, and this is my Physics 2212 Lab 5. The goals for this lab were comprehending the application of Faraday's law by collecting data of a magnet falling through an aluminum tube, and also creating computational models of these interactions using GlowScript. Some of the results were the observed time of about 1.3 seconds on average, and the computational model predicted time of about 1.1 seconds on average. Some of the important physics concepts that were used for this lab were Faraday's law and Biot-Savart law, along with F equals ma and the gravitational force law. For the experimental observation portion of this lab, the system was the magnet and the aluminum tube, as can be seen on the image on the right, and the surroundings was everything else. The steps for this observation included identifying the north pole of the magnet using the magna magnetometer app and marking it on the magnet, and then filming a video of the magnet being dropped through the aluminum tube. Then that process would be repeated 4 more times to get 5 different trials. And then using the video recordings of the magnet falling through the tubes, we will then measure how long it took the magnet to fall through the tube in each trial, and then get an average. Here you can see some of the data from the observation part of the lab for each trial and the time it took on average to get through the tube. And then some of the measurements can be seen on the right with the length being 0.3 meters, the width being 0.006, the radius being 0.03, and the inner radius being 0.02. For the computational model, you can see some of the code I used for it. And then on the right, you can see an image of what it looked like with the magnet falling through the tube on the output of the code. Some of the assumptions for this lab were that air resistance was negligible, and that the magnetic force from the aluminum tube and gravity were the only forces that were acting on the magnet as it fell through the aluminum tube. Some potential sources of error included inaccurate measurements and errors in calculations of the time it took the magnet to fall through the tube in each of the trials. For the questions, what if the resistivity of the conductor were reduced as close as possible to zero? How would the dynamics of the falling magnet change? In this case, the induced current in the aluminum tube would be higher, which would create a much stronger magnetic force on the magnet, causing the magnet to fall through the tube much slower. And then the other question was, what if holes or slots were cut into the tube? How would this affect the ring currents in my model? So in this case, the induced current in the aluminum tube would be actually lower, which would create a weaker magnetic force on the magnet, and as a result, the magnet would likely fall through the tube much faster, facing little to no resistance as it falls. Thank you.